All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll show you the correct answers. For this factoring, you're going to have to start by removing your 7. So you're going to have x squared plus 19x plus 70. And then when you go to factor, you want to make sure to replace the 7. And the numbers that you're going to want to use are 14 and 5. The first set will reduce by 7, and then the second will not. And so this is what you would have for your answer. For the math knowledge question, if you look, the way the answers are written are a little bit strange because they're not decimals. They're in terms of sine, cosine, and tangent. On the ACT, they say that you can do every question without a calculator. And so since you don't know the sine, cosine, or tangent of 65, they leave it in the answer. Now, what we're going to want to do is figure out this part here, and I'm going to label it as y, and then we know that x plus y has to equal 20, because this part here is x, and this whole thing is 20. So we're going to use this triangle right here. I'm going to draw it a little bit bigger. We know that the base of that triangle is 4, this angle is 65, and we're looking for that y. So if you use tangent of 65, you're going to get y over 4. So multiply both sides by 4, and you have that y is 4 tangent of 65. And so then we know that x plus 4 tangent of 65, because x plus y, that equals 20. And so if you solve for x, you'd have 20 minus 4 tangent of 65, which is going to be A. Now, there are multiple ways to solve it. You won't get that exact equation if you solve it a different way, but you can just plug all 5 of those in the calculator, and then whichever decimal matches up with your answer would be the right one. So you can do it that way. We're looking at lesson 70 today, dealing with percentiles and z-scores. We're going to look at percentiles and z-scores. Hopefully you'll understand that after the lesson. In order to do these, you have to have this chart here. And so I have a chart for y'all. It is blue. It's on cardstock. I have laminated it for you. You must keep up with it because you'll need it for your test. They're not going to give you a chart on the test. You'll have to use the blue one. So if you lose your blue one, you cannot share with another student during the test. You will either have to go make another one, or give me $1 and I'll go get more made for you, or you'll have to do without. But at the end of the year, you have to turn this back in, and if you fail to turn it in, you have to turn in $1 so that I can go get more paper and get it laminated. Okay, so keep up with it. Keep it in your book or in your notebook, wherever you're going to always have it here in class when you need it, okay? So this is how you get the number that you're even going to look at on your chart. You're going to get your z-score by saying the data minus the mean over the standard deviation, which right now you don't really know. You know what standard deviation, you know how to find it, but you don't really know what that means whenever I say data minus mean over standard deviation. But that's the formula that you're going to use in order to get the z-score. And so I like to shorten it as x minus mu over our standard deviation symbol. But if you would rather write it out every time, you can. Remember that little symbol down there is the sigma. It's a Greek letter. Okay, so let's look at an example. So here is my z-score table, and I'm going to show you how to use it in just a minute. We have the mean weight of the babies born in a hospital for 7 years was 6.8 pounds, with a standard deviation of 0.8 pounds. If the distribution of weights were approximately normal, what percent of the babies weighed less than 6.4 pounds? So we are going to use our formula to find our z-score. We have data minus mean over the standard deviation. So our mean that they give us, the mean was 6.8. and the standard deviation was 0.8. The data that they want us to look at is less than 6.4 pounds. Okay, so we're going to use 6.4. So if you plug that into your calculator, you're going to get 0.5, and it's going to be negative. And the negative is important. So we're going to look at our little chart here, and we're going to go to negative 0.5. So the way you do that, they have a 0 and they have a negative 0. Well, we're going to use the negative 0 because if you look, our number here is negative 0. So negative 0, and then our decimal is 0.5. So this would be negative 0.0, 0.1, 0.2, 0.3, 0.4, and 0.5. So this number here is the number that we're going to use because that's negative 0.5. So it's 0.3085, which if you put that as a percent, is 30.85%. And the number that you get from your chart here, that number right there, it's always going to be the amount that is less than whatever data they gave you. So if this one had asked for the percent of babies that is more than 6.4 pounds, you would say 100% minus that 30.85%. But the number that you're going to get on your chart is always going to be the amount that is less than 6.4 pounds. So I'm going to draw a picture. We had talked about bell curves, where we have the mean here, and then within one standard deviation is 68%. Within two standard deviations is 95%. And then within three standard deviations is 99%. On this one, they told us the mean was 6.8, and then the standard deviation was 0.8. So that means that this would be 6, and this would be 7.6. And we were looking at 6.4, which falls about right here, somewhere in here. We don't really know exactly where it is, but we know that it's going to be less than half of the babies because it's less than the average. And so this allows you to actually compute it for numbers that aren't exactly one standard deviation or two standard deviations away from your mean. Okay? So let's look at another example. We're going to use the same information from the previous example, but this time we want to look at the percentage of babies that weigh between 6 and 7 pounds. So in order to do that, we're going to have to do it 2 times. And we're going to do first for the 6-pounders. So our data that we're looking at is 6. And then if you go back, our mean was 6.8 and our standard deviation was 0.8. .8 and 0.8. And if you plug that in, you're going to get negative 1.0. And we're going to go ahead and find the z-score number for the 7-pound babies. And if you plug that in, you get 0.25. Okay? So, now that we have our negative 1.0, we're going to go to our little sheet, our little chart. And we've got negative 1, and then we've got 0.0. So that's 15.87. So I'm going to write that as a percentage. That's that number right here. 15.87%. Now, for the 7-pounders, we had 0.25, 0.2.3. I don't have 0.25 on my chart, do you? How can I get what 0.25 is? Well, you can take these two numbers and average them together. Okay? So we're going to take the 0.2 and the 0.3 numbers right here, and we're going to average those together. And if you average those, you end up getting 0.5986. So that's going to be 59.86%. Okay, so now that you have those two numbers, I'm going to draw a little chart to help you visualize where they are being used in your bell curve. So there's my bell curve, and that is the 6.8, and the 7 is here, and the 6 is over here. What we found with this 15.87 here is the amount of babies that are under 6 pounds. So that would be this part right here. And then what we found with the ones that are 7 pounds, that is all of these here, and they are 59.86%. But what we're concerned with is the part that is from 6 to 7. We want this part right here that I colored green. And the way that you're going to do that, you're going to say 59.86% minus 15.87%, because they overlap in that 15.87% on the left. And so if you subtract those, you should get 43.99%. And so that's the percentage of babies that are in between 6 and 7 pounds. Okay? Looking at one more example. It says in the same hospital, what percentage of the babies weighed more than 7.2 pounds? So again, we're using the same data that they gave us from the last one. So our mean is going to be 6.8 and our standard deviation is 0.8. So the data we are concerned with in this one is 7.2. So if you subtract those, you're going to get, and then divide, you get 0.5. So if you look on your chart, you're going to look at this one right here. You can go over to 0 and then 0.5. So you're going to have 69.15%. But that is the amount that is less than 7.2 pounds. We want to know the ones that weigh more than 7.2 pounds. So we do 100% minus the 69.15%. And we end up getting 30.85%. And so that would be the amount that weighs more than 7.2 pounds. So again, whenever you go to your card, the percent that you get is the amount that is less than whatever data they gave you. Okay? So definitely keep up with your card. Don't lose it. You'll need it on your test. You'll need it for your homework too. But they do have a copy of the chart in your book if you want to keep flipping back to it. So hopefully that helps you a little bit with percentiles and z-scores. Your homework, you don't have any to omit. Make sure to do that tonight so that we can go over any questions you have tomorrow.